Okay, guys, we're gonna talk about CT scanners. This is CT scanner.
দেখা যায় না because of the light.
Yeah, I'm trying to look. Consider when buying a new CT scanner. But okay, I'll turn this light off. Oh, different colors.
Brightness বাড়া দাও এটার.
Hey, there you go. Yes. So that's a CT scanner right there. That's another CT scanner, right? That's from
Doesn't
Wikipedia.
the head go in first?
Depends. Like, well, yes, usually the head goes in first. All right. So, what I'm going to do now is I'm going to show you a video on YouTube of a CT scanner doing its thing. Okay, look, this is CT scanner. Oh, it looks so real, man. Like in the video. And look, this is it spinning.
That looks like a bagel. I'm so hungry. That looks like a bagel to me. Can
Oh, I thought you said it looked like bumblebee.
No, man. It looks like a bagel. I'm super hungry.
Wait, so you're the kind donut ke bagel bolde?
Nah, like an actual bagel.
Bagel.
Yeah.
Bagel. So that's a CT scanner. So basically the point is it spins and patients don't go inside there. If you could see it spin, they would freak out and die. So that's why you don't show that stuff.
Yeah, that is pretty scary.
That's pretty scary, I'll agree to that. Do you want your head there?
Nah, this is making me dizzy already.
Just imagine, if it suddenly touches you.
Great.
Look, it's a little bit of CT scanner and mystery student.
Really bad joke, but never mind. Don't be disconnected from it.
Shut up. Shut up, Maksud. Maksud is cracking really bad jokes. So basically this is what a CT scanner looks like. It's this crazy thing which keeps spinning like crazy. I always like showing this video because
Yo, how does that thing spin?
it uses motors.
But like, what type?
What do you mean what type? Powerful types.
Doesn't go through the middle.
Alright, so yes, that's basically a CT scanner. Are there any other videos we want to show? Oh, and obviously there's more CT scanner spinning videos. You guys can just watch it on YouTube, and you'll be able to find out the different types of CT scanners there are. So this is the basic concept behind the CT scanner.
I should follow this.
Yes, follow this. Maksud, pay attention. So yes, CT scanners fundamentally use X-rays, all right? What they do is they basically send X-rays through, these are the two parts which would be spinning, and this would be the object of the patient's body. So X-ray tube passes through. This is a collimator. The job of the collimator is basically making the beams parallel. So once the beams do become parallel, then what happens is they pass straight through the patient, and then this is the detector which moves with the whole thing. So as it moves, it basically does scans from different angles. So that's what we're trying to do. We're trying to create an image from different angles, from this angle, from this angle, from this angle, and do that. So yes, please read through all of this, the basic ideas of how we use CT scanners. And the idea is it's going to do a scan, and then it's going to move at an angle. Hey, Mahdi sir's here. Mahdi sir teaches bio. Really nice guy. He's a really nice guy.
It's the biomati, sir.
Yeah. Like the Mahdi sir.
Yeah.
Like, not a Mahdi sir.
I mean the doubles.
Yes. I will not disagree with you. So, Kemun aছেন, Mahdi sir? I hope you're good. And, he sends me messages, to RT, saying, Cholen, Fortnite খেলি. He's really cool. Anyway.
That's nice.
That is top-notch banter, man.
I know, that's top-notch banter, I know. So, anyway, moving on. So yes, you raised your hand, Max.
What does the collimator, what is it made up of?
It's usually made of radio opaque material like lead, so that it blocks out all of the beams which are going bent and only allows the ones which are going straight, right? And basically we end up doing it from different angles. And that's what we do. All right, moving on. If you read through all of this boring stuff, you'll realize that it's very boring. And at the end of it, there's this interesting thing where basically it's like this pixel concept, where basically CT scanners break down the entire tissue into these little voxels, all right? So if I was to break them into this, each voxel has a different intensity. So from these values, we can actually figure out what this tissue is made of. So if you had if we have a lot of pixels like this, you can actually create a pretty decent pattern, right? From which we can find out an image. So if you guys haven't seen what CT scans look like, I think I should take a moment and show them what CT scans look like.
Yeah, sure.
yeah, what should be the end result of CT scan. So what I'm going to do is I'm just going to Google CT scan, not scanner, CT scan. Yeah, I'll get rid of all of my. Okay, this is what a CT scan looks like. You've seen this on, like, Kijani, House.
House MD was
That was the
on it.
best.
I
That was the
love
best.
that show.
Yes, my God.
And,
I thought you'd watch Grey's Anatomy or
Oh
something.
no, I don't like Grey's Anatomy.
Grey's Anatomy is just wrong.
Drama, yeah.
Wrong. It's just wrong. It makes doctors look really inappropriate, and I do not support Grey's Anatomy whatsoever.
But House is alright.
So then they do this really cool
Yeah,
thing.
the
Oh,
brand
check
is
this
so
out, guys. You guys really need to check this out. I hope this loads fast enough. So yes, this is basically as the CT scanner scans different slices, you can add up these slices. Oh, that's a
that a
tumor, right?
tumor?
Yes, that was a small tumor.
Sad.
So basically different slices, and you can see through the patient's head through these different slices. This was the base of the skull, then we have parts of the brain right here, and then we have brain ventricles and everything, and that was that little red circle. And yes, so yeah, there's a lot of other stuff actually in that scan, but yes, let's not get too technical. And then there's other videos also, there's this one. This one should look cool, right? This is basically a section through the head.
Oh, you can see the eyeball.
Oh, yeah, there's the eyeball. Oh wow, that's the nasal cavity, parts of the brain, corpus callosum, brainstem, and then you have there it is. Then the ventricle, you have the third ventricle. Was it the fourth? Oh.
Lex, we get it. You're a doctor.
Yeah, I'm a doctor, guys. I'm a doctor. I'm a doctor. I'm a doctor. Mahdi sir says, let's play RDR2. So yes, this is basically what the slices of the CT scan is, right? So basically we create these images using that pixel intensity stuff going on. So we get them in different layers and different intensities. And that's how it is. All right. So there's an interesting thing that we can do with all of these sort of scans is we can put them all together and we can actually create 3D images. And oh man, this one's crazy.
It's too graphic.
Let's see. Don't get scared, guys. Looks like Maqsadul when he laughs.
I'm not gonna lie.
All right. So yes, this is basically a 3D
Yo,
image.
What's that?
Which one? Oh, no. We're not watching that. We're not watching that either. So this is an ankle. Oh yes, that looks cool, doesn't it? So this is basically a CT scan which shows the different parts of the ankle joint after a surgery. And that's what we get. So yes, and then we have one last CT scan. Looks pretty scary, doesn't it? So that's basically the rib cage, all right? And we can look at it from different angles. Yeah, it looks very Mortal Kombat-y. It's from 1983. Isn't that crazy?
This reminds me of House of Dead or
Oh please, come on! No, we've already talked about that today.
The first one, I don't know.
I don't remember.
Yeah,
Was it
I
like-
only did the first one. House of the
And one last video. So oh look at that! That's the backbone. Something you don't have. I won't be mean anymore. I'm a nice person. Lol. All right. So basically, how do we create those images? We have this voxel intensity thing going on, from which we can calculate and find it out. So let's get to that. So there's a few steps that we have to take for calculating that value and finding it. So what we're going to do is, yes, thank you, Maqsud. You can take this too. So what we can do is basically we can start off from here, 4127, right? So 4127 is basically the the pixel intensities of different parts. So yes, these are basically the intensities that we need to figure out. In reality, obviously, there's going to be millions of pixels. They're just showing 2x2 combination here to make life easy. All right. So what happens is, first of all, this is basically the side where we have the source, the collimator, and it releases parallel beam of X-rays from this side. And as it passes through, you say, if it takes this route, it gets a total intensity of 4 plus 1, which is 5, and 2 plus 7, which is 9. So what happens is it stores it in its memory, right? So the computer that is doing it stores it in its memory as 5599. And then what happens is it repeats it from a 45-degree angle. So if you do it from the 45-degree angle, we have 2, we have 4 plus 7, 11, and we have 1. So we have 1, 11, and 2. And what we do is we add it to this previous setup that we had. So 2 plus 11 plus 1, and we add it along the roots in which we got it. So this would be 11, this would be 11, this would be 1, this would be 2. So basically this plus this gives us this. So this is basically two angles. We got one angle, then we got the second angle after 45 degrees, and then we rotate it another 45 degrees, and we get this. So basically 4 plus 2, we get 6 here, 1 plus 7, we get 8 here. And then 6, 8, 16, 6, 11, 20, that gives us 22, 14, 17, 28. And that's the value we get. And then after that, we move on to another 45 degrees. And basically 4, 1, 2, 7 again. So basically here, we're going to get 4 through this, we're going to get 3 through this, and we're going to get 7 through this, right? So basically that's exactly what 4, 3, and 7. Quality is going down a bit. Achha, please slow down it too. Okay, we'll go slower. But there isn't, I'll just go through it again, don't worry. So basically it adds up. So basically the 437, if we add it to a previous record, it becomes 26, 17, 20, 35. So notice how many did we do? We'll just go through that again. So we started with 4127. We did it from this side. We got 5 and 9. So we stored that as 5 and 9 in our computer memory as 5599 based on the path it took. And then we do that again from this angle. So it's going to be 1, 11, and 2. And then we add that 1, 11, 2 with 5599. And we get basically 16, 6, 11, 20. Right. And then we go on. And we basically, this was because we added this onto this. Basically, we're adding the value we get in each angle with the next angle. Oh, battery's going low. And then we repeat this again for this angle, which is going to be 4, 11, 2, and 7. And for this, we get 6 and 8 here. And then we add that 6 and 8 to our store, which is 16, 6, 11, 20 from the previous record. If we add it up, we get 22, 14, 7, and 28. And then repeat it from this angle, 4, 1, 2, 7, 4, 3, 7. So basically the 1 and the 2 is the 3. And then we add these values according to the locations they're in. So it basically becomes 26, 17, 20, 35. So this is how far we got. This is how we do it. And then moving on. So this is our final result. So we need to find the 4127 from this. So there's 2 steps to finding it. Step 1 is, if you notice, from every value that we calculated, the detector gets the same reading every time. 15 plus 9, 14. 1, 11, 2, 14. And then 6 plus 8, 14. 4 plus 3 plus 7, 14. So basically every time we get the same value. This is called the background. So we basically subtract that. So in order to obtain the original pattern of pixels, 2 operations must be performed. Operation number 1, the background intensity must be removed. The background intensity is the total of each set of detector readings. In this case, 14 is deducted from each pixel. And after that, after you deduct that, we get 12, 3, 6, and 21. After you deduct that, what you have to do is you have to divide, after deduction of the background, the result must be divided by 3 to allow the duplication of the views of this section. So basically, because we did it from 4 different angles, we get rid of one angle by subtracting background, and you get rid of the other 3 by dividing it by 3. And voila, you have 4127 from that information. And that is basically it. Right, I would strongly suggest that you actually go through this once, the papers, to figure out how it exactly works. And if we go through the reading here, there's a bit of information which is important here, so I'll just read through it very quickly. In practice, the image of each section is built up from many small pixels, each viewed from many different angles. The collection of the data and its construction into a display on a screen requires a powerful computer and complicated programs. In fact, the reconstruction of each pixel intensity value requires more than 1 million computations. The contrast and the brightness of the image section as viewed on the TV screen can be varied to achieve optimum results. In order to build up an image of the whole body, the procedure would be repeated for further sections or slices through the body. All the data from the sections can be stored in the computer memory to create a 3-dimensional image, the images that I showed. And views of the body from different angles may be constructed. So this brings us to a specific question that they always love to ask. Maqsood has done us a wonderful favor of actually identifying one of these questions. Outline the principles of computed tomography. So when they ask this, and if it's a 6-mark question, as they show it here, there's a couple of specific answers. Answer koi aisa? Oh yes, there it is. Yes. So realize you'll have to read the nature of the question. They want the principles of it, right? So what are the principles of it? How would you write the answer? Basically, these are the steps. X-rays of a single slice are taken from the patient, and they're taken from different angles or by rotating X-ray beam. So if you write that, you get 2 marks. The next 2 marks is a computer is used to build up an image, which is a 2-dimensional image of the slice. And this is repeated for many different slices, adjacent slices, to build up a 3D image. There you go, and that's it. Easy peasy. That's how you write these answers. I went a little quick with that, but if you want to find out where it's from 97024 to October, November 2016. So yes, that's that. And there's a lot of other bunch of questions here. For example, the radiation dose by a patient, received by a patient CT scan. For that, a simple X-ray image. What about this? Gives increased exposure to radiation. Explain why a radiation dose received by is different for a CT than that from a simple X-ray image. So why would that be? Maksud, any idea? Come on, it's an easy question.
Making a 3D image and more slices. You're trying to...
Well, okay. Yes. CT scan consists of many X-ray images of a slice. There are many slices. X-ray image is a single exposure. So much greater exposure with CT scan. Right? So we try to avoid CT scans for people who might, for who it might be risky, for example, pregnant women. And here another one, we have briefly the principles of CT scanning, is the same concept again. Oh, and they've given this calculation. It's basically the same steps. Step 1, they want you to find the background, or have they given the background? They should. Background is 34. So what do? You subtract 34 from each one, right? So what's going to be the value if you subtract 34 from each one? Can you tell me, Maksud? Come on, get your calculator. Good job.
Minus 34.
Yes, 49 minus 34 is
15.
Oh wow. 61 minus 34. Oh wow.
73 minus 34 was it?
Oh wow.
59 minus 34. 21.
All right. And if we divide all of these values by 3, because those are the 2 steps, right? So it's going to be 15 divided by 3 is 5. 27 divided by 3 is 9. And 30 divided by 3 is 13. And 21 divided by 3 is 7. And that's basically the answers of our value. Done. Easy peasy.
Lemon squeezy, huh?
Easy peasy, lemon squeezy, yeah. So 5, 9, 7, and 13. All right, we're done with that. And that concludes CT scanners for tonight.